So in this question, we're going to look at a standard contextual differential equation. So the value of v pounds of a long-term investment may be modelled as a continuous variable. At time t years, the rate of increase of v is directly proportional to the value of v. So first of all, write down a differential equation well. If we were doing this in GCSE, the first stage we would do is we'd say, well, hang on a minute then. The rate of change of value with respect to time, dv by dt, is directly proportional to v. And obviously it's positive v because it's increasing. Now, if I wanted to then put this into an equation, I would put in a constant. So I would write dv by dt is equal to kv. Part B, show that v equals a e to the kt, where a and k are constants. Well, we go back to our previous video, and what we need to do now is separate out the variables. So the first thing I'm going to do is multiply through by dt. So I get dv is equal to kv dt. Dividing through by v, I get 1 over v dv is equal to k dt. Now, if you recall, at this stage, we've got our v's on one side, t's on the other. So I'm going to integrate both sides. And the integral of 1 over v is the natural log of v. And integral of k is just kt plus c. Remember, the constants are all going to be pushed over to one side. From there, I need to get v by itself, so I'm going to raise everything up to the power of e. So e ln v is equal to e to the kt plus c. The e and the ln cancels out, leaving me with v. And if you recall our rules of interz's from the previous video, I can write this as e to the kt times e to the c. And I'm going to say, well, hang on a minute. E to the c we can just call a constant a. That's going to give us v is equal to a e to the kt. So there's my general solution. Now in C, we get some additional information. The investment after 2 years is 292 and the value after 28 years is 637. Show that k is equal to 0.03 corrected to 2dp. So for part 1, I'm just going to sub in the solutions, the information to my two equations. So the value was 637 after 28 years. So that's AE to the 28k. And it was worth 292 after 2 years. Now, what I can do here, I've got simultaneous equations. I can just divide both of them. That leaves me with 637 divided by 292 is equal to, well, the a's cancel and rules of indices, divide you take away, will give me 26k. If I find k, if I take the natural log of both sides, I get the natural log of 637 over 292 is equal to 26k. So dividing through by 26, I will get a value of 0.03 is equal to k. Now in part 2, it asks for what is the value of a. Well, again, we can just substitute in, and we've got our new equation now. V is equal to a e to 0.03t. Well, I know that the value was 292 when t was 2, so I can substitute that in. That gives me 0.06. So basically, if I do 292 divided by e to the 0.06, I get a, which comes out to be 275. The final part was, what is the initial value? Well, my final equation now is v is equal to 275 e to 0.03t. Well, initial means when t is 0. So v will equal 275 e to the 0. That's 1. V would therefore be 275. So the initial value, v0, is 2.